Hello everyone and good to see you again. I'm back and hopefully you are as well because we'll continue today our discussion on Spring Start here. I've left this in the middle, not even the middle. I think I've covered just a little bit more than 3 chapters and I'm happy to be finally back. Remember, if you are watching the event live, you have the live chat there and we can continue our discussions. And if you are here for the first time, subscribe and share the channel with others if you like it. And yeah, let's continue with our discussion and looking forward to all your questions as usual. And follow me also on the other social media if you want to discuss more with me. I'm gonna step directly into the juicy part because I know you are here for the detailed information that we are going to discuss, and you know that in this series we talk about the contents of Spring Start here, and I'm going through all the chapters. And in the previous episodes I have already discussed up to section 4.2. Very important is, if you need a refresher, to go back and review what we have already discussed. This first part called fundamentals of the book is really important if you want to become proficient with Spring. Remember today what makes the difference between someone who simply knows a little bit of Spring, like for example student like, and the real Spring professional is knowing the details behind the scenes. And this is something that even at the moment, from my point of view, AI can't replace. No, so because I know a lot of people are still afraid about AI taking their jobs, which I don't think it will happen soon, no worries. But still, using AI as a tool will not help you if you don't already know the details that I want to teach you, these details that we talk in this first part, one of the fundamentals. So very important before jumping into this video, make sure that you know all the other things that we have discussed, especially how to define beans. Remember the 2 ways defining beans, the 2, let's say, modern current ways defining beans, using the @bean annotation and using stereotype annotations. Of course you can do that programmatically as well using the register bean method, but still that's not something you see quite often. And of course I don't talk anymore about the XML declarations because that's something that today hopefully you shouldn't see anymore. I know there are still mammoth old projects out there still having dependency injection and declaration through XML files, but normally that's something that hopefully in the future you will not see anymore. So I'm only focusing on annotations for this reason. And of course wiring and auto wiring the beans using the dependency injection. No, that's one of the implementations over inversion of control over IOC. And what I was teaching you in this chapter 4, I'm now making a refresher for you guys. What I was teaching you in this chapter 4 is that you can even use abstractions. And here, very important, when I say abstractions, I specifically refer to interfaces, because the interfaces, they are the ways to declare contracts in Java. So very important to remember how interfaces work and remember the difference between interfaces and other structures that the Java language offer, like classes, abstract classes, enums, and the records. And very important, when I say the difference, I mean particularly the difference of using them, because one of the things that I observe in the real world out there, especially with students, entry levels and beginners, is that they focus too much on syntactical things, on technicalities, instead of focusing on what exactly that structure is and why do we use it. So for example, I see this problem with interfaces versus abstract classes. Sometimes I have technical interviews with more junior entry-level people, and I see that they do focus a lot on the differences, on the technical differences between what an abstract class is. For example, you can declare fields in an abstract class, but you can't declare fields in an interface. Totally correct. Yeah, you can only have static fields in an interface, and you cannot have, but you can have non-static fields in an abstract class. Fine, totally correct. But the question is why? And then what's usually these people don't know how to tell me is why. And that's the problem actually, because you shouldn't focus only and not even too much on the technicalities as much as on the usefulness of each of these structures. Why is that particular structure important? So that's why is, first of all, before diving into this section 4.2, I have created this section 4.1 where we discussed particularly only about interfaces and the usage of interfaces with an example, and that's what we've done in the previous episode. And now we continue finally and we talk about the usage of the interfaces in Spring. So that's what I want you to know as an intro to our today's episode. Is I want you to understand that it's particularly important before understanding that we can use interfaces with Spring, and normally with, I would say, all the frameworks out there, but today we talk about Spring now. Before using them within frameworks, within applications with specific frameworks, understand their meaning, understand what the contract is and where we use it. And look, I will tell you today about different places where they are misused. I work as a consultant and I see many projects, and in many projects you will be surprised in how many projects I see today interfaces wrongly used. Wrongly meaning in special when talking about the maintainability and the structure of a project, making that project, using that interface in a really useful way and not just putting it there to exist, which is normally what we call over-engineering, a complexity that you add to the application where it's not necessarily needed. Yeah, I see your messages. I also say hi, thank you very much, and I will take a couple of minutes to see your messages and see if you have questions. So someone is asking if I've been watching some podcast, which I haven't, no, but I will put it on my list. And we invited Zuckerberg and talked about the AI from Meta, which can write code as mid-level engineers. I don't doubt that Meta can, and not only them, or maybe ChatGPT as well, can write code maybe as even senior engineers. I mean, let's talk. I will just make a short parenthesis because today's episode is not about that, but maybe I will create a separate live event about talking about AI more because it makes sense. But as a matter of fact, I'm now using AI even for writing my books. That doesn't mean that when I use AI for writing the books, I just tell ChatGPT, hey, write this chapter for me, and then instantaneously ChatGPT writes the chapter for me. No, that wouldn't make sense, because when I write that chapter, I want to put my knowledge and experience into that chapter. So when I'm using ChatGPT, I'm simply using it for rephrasing some paragraphs, for making them better because I'm not a native English speaker, and that's how I enhance. Sometimes I'm even asking ChatGPT to remind me of some stuff. But pay attention, remind me. It's stuff that I already know. I just want to refresh my memory. So we will use, even with that AI being able to write code as a mid-level, senior level developer, whatever you name it, it will still be, first of all, before we reach the point where you will have AI writing the code, there will be plenty of years of using it as a tool to help you rather than do the stuff for you. It will not be AI first, but people first. That's the difference. So no, I'm not afraid about the AI. I really am not afraid about it. It's not only for like making a strong face here. So explains until Kafka. Okay, let's go into Kafka into another episode. And the books, are you working on new edition of Troubleshooting Java? Yes, I do. And I will include this couple of years experience of using AI tools in troubleshooting Java applications. So the new stuff that comes into the troubleshooting Java are a couple of chapters about the compiler and the logs from the garbage collector as well, and a lot of stuff about my experience with AI in troubleshooting Java applications, from debugging to profiling to heap dump analysis to thread dump analysis and so on and so forth. And I want you to know I'm a happy user of AI. And in the past couple of years, since the hype started, I've been using most of the tools in real world applications. So that's what I'm going to share my experience with that, what happened with what I've learned about these tools in the past couple of years. Now, let's go back to our book and discuss about these abstractions now. And I want you to see some example, no, because we always understand it better through examples. So remember, we talked about how we use interfaces, and we said that contracts are important only when it makes sense, only when you anticipate that you will have to replace an implementation with another, either dynamically within the execution of the application, or you have simply multiple implementations that make sense, but you want to facilitate one way of using them. That's, for example, what Spring Data does. We will talk about Spring Data a little bit later. I think it's chapter 12 now, where we'll discuss a bit about Spring Data or a bit more. But the point is, it doesn't make sense to use them everywhere. And I promised you I will tell you also about places where I've seen in real world applications interfaces not being used correctly. Many applications, for example, you have a normal standard linear layered architecture, that one that we use very often also within examples, where you have the services class, the controllers class, the model, proxies, and so on and so forth. And I do still see in many projects like all this having interfaces attached to them. But do interfaces make sense for all these cases? Well, no, we have to properly think before writing an implementation if it makes sense to abstract it somehow. Service classes, in my experience, are almost always never needing a contract attached to them. And I still see things like services and then the implementation. And even in many cases when I'm doing this consultancy service, the teams ask me, hey, why did we need an interface for the services there? Because I don't understand. And then I do answer them, well, I don't understand either. Normally it's a design mistake, because you don't need, again, that would simply become just a non-useful interface, an over-engineering. But it makes sense, for example, when you use them with repositories, and that's why, for example, Spring Data uses them, and we will talk about it in one of the next chapters, is because you have plenty of different persistence solutions. And not only that, you have plenty of different persistent solutions, like, for example, you can persist in a relational database or in one of the many non-relational databases technologies. But you also have different ways of managing all this. For example, you might have, first of all, the difference between using the persistent solution reactive versus non-reactive. When we talk about strictly relational databases, you have the possibility of using plain JDBC versus using a JPA implementation. So you see, you have a lot of manners of implementing the same thing. And that's why for repositories, it always makes sense using interfaces to provide a contract that defines one way of using the same thing regardless of the implementation chosen, and especially for a framework such as Spring. And that's why Spring Data implements that. It makes a lot of sense because it wants to provide you with a solution where you learn a way of using something regardless of the many possibilities of implementing that something. And in the same way, you could say that usually proxy classes, which are classes usually implementing the communication with another system. Remember, implementing the communication with another system may be done in several ways. You might want to implement it using a normal RPC like REST or gRPC, for example. And then in that case, maybe you want to implement an interface such that maybe in the future, if you want to change the implementation, you now implement them using a REST approach, but later you want to change to gRPC, it doesn't affect the way in which this layer of the proxy communicates with the service that implements the business logic, because the business logic is simply business logic. It just tells what happens when the user clicks a specific button. It doesn't have to be any way linked to technicalities such as how do we communicate with a specific other system. That should be transparent for the business. Business is business. It means processing the data in a particular way that is defined by the enterprise for which we implement the software. Technicalities such as securing the application, sending messaging, persisting data, and so on and so forth, they should be completely decoupled. So that's what we decoupled, okay? And that's, for example, in this case, this diagram that I put in the book just gives an example that makes then the life easier for explaining. So if you read what I wrote above, you will see that this is basically the service. This publish comment is the use case. It implements the business logic like any other method from a service class. It uses a repository and the proxy class. But what you observe that in this case, I decided to decouple the repository and the proxy through contracts by means of using, of course, interfaces, because they are the structures providing us this capability in Java. So you can see here that, again, I decided to do that because I want to decouple the business logic from the technicalities of whatever I want to use here or here to implement the functional technical part of what this proxy does. So for this particular example, the proxy, for example, is it says a comment service is storing a comment, and then we can assume it sends an email with that comment to a particular email address. But we assume that in the future we don't know if we will change the way we store the comment. Maybe today we store it in a relational database, but later we'll want to change that and use a NoSQL database, or maybe today we use plain JDBC, and then later on we would like to change to using a JPA, an ORM implementation. Here the same, today we send an email, but maybe tomorrow we want to send a push notification, or maybe we want to send an SMS, or maybe we want to, I don't know, post a message somewhere on WhatsApp. There are so many possibilities. That's why we create the interface. That's why we use the contract, because we don't want this to change in regards to what we use here. So we do use interfaces only in this case, okay? And then look what we do. We define the interface, and then we write the class that implements the interface, and somehow using any of the approaches that we discussed here in chapter 2, we make this a bean in the Spring context. So remember, you can do that using a stereotype annotation such as @comment in my case here in listing 4.8, or it could have been using the @bean annotation over a method in a configuration class. So that's basically what I do with the same. So the interfaces, they are pretty, I'm not sure if I have the code for the interfaces here, but they only do define the methods, and then you come with the implementation here and you make the class a component so that Spring knows to create a bean, to create an instance and store it and manage it into its own context. Yeah. Remember, if these things sound strange or unknown for you, they are really important to understand first before you dive into this chapter. So you will have to refresh your memory with the first 3 chapters, which you can still find them here on this channel. No? And look what we did here. You can see that I do still declare them as attributes. I'm using here a constructor dependency injection approach, which you remember, hopefully it's the recommended way. So I define the fields as final to ensure immutability of my service class, and then I use a constructor with the 2 parameters providing the values for the comment repository and the comment notification proxy. And what we observe here is that we do not use the class names. See, I'm not using either the DB comment repository or the email comment notification proxy class. I'm using for both of the cases the interfaces. And the reason I'm using the interfaces is because I want to keep the comment service class completely decoupled. That's why I created the contracts. I want to work through contracts. And what we observe is that Spring is smart enough to know that when I'm using here the dependency injection through an interface, what I want is I want it to provide me an implementation, because I cannot have, of course, an instance of an interface, because interfaces cannot be instantiated, because interfaces in Java, they simply define contracts, they are not implementations. So reason why Spring needs to search for an implementation that resembles with the interface and provide it as a value of the parameters of the constructor, auto-wiring it this way in the fields. And Spring knows how to do that. Of course, there are some situations. If there is only one implementation in the Spring context, then it's easy. It will always provide that one. If we have no implementation for that interface, then you will end up with an exception. Spring will tell you, hey, you told me to give you an implementation of comment repository type, but there is no bean in the context of a class implementing this interface. Or you might have more than one case in which you either have to define one of the types as a primary type using the @primary annotation that you might also remember from the previous chapters because we have discussed it, or you have to use the @qualifier annotation for name dependency or dependency injection by name instead of by type, which rarely happens. Okay, I see some more comments, so let me read and see if I have something that I can answer. Lectures on testing, I will put them on my list. Yeah, I'm planning to write a lot of to create a lot of content this year, so stay tuned with me. Service mesh and DSTO also very nice subjects. And I know, yeah, I mean, you say software architecture playlist is not completed. It can never be. No, software architecture is something that never ends in my perspective. So yeah, I will try to add some subject on that as well. In commercial project, do you create constructor by yourself or use Lombok? Very good question. Personally, I like using Lombok. I know there are two sides here, and I know some people are for some reason upset about Lombok, but to be honest, if you use it only in simple features and maybe you don't abuse of it, I feel that Lombok always helped me minimize the number of lines of code in my project. So for example, I'm particularly strictly using it for eliminating the constructor using either the all args constructor or the required args constructor annotations, or the no args constructor if I want a constructor with no arguments, but that rarely happens, to eliminate the getters and the setters, and that's it. So, and builder classes sometimes, yeah, builder classes. I do avoid using Lombok for the toString method, and I do avoid creating the equals and hash code methods with Lombok, and that's why I also avoid the data annotation because of that. So I keep it simple, but yeah, it helps me, and particularly here using Lombok, for example, it will spare you, for example, all these 5-6 lines of code here only by putting an annotation above the class. So hello, wrote to you via LinkedIn. I will try to answer the messages. I know had a busy time and didn't have time to answer the messages. I will go through them. I see many people using the qualifier for beans even if the method name is different and it is not needed. What do you prefer? I'm not sure if I understand what you mean by even if the method name is different. So normally qualifier, you can use it in multiple ways. You can use it, for example, in this case here, if you want to particularly say, hey, I have multiple implementations and I want this specific one to be used. So what you do, you go with that qualifier and you name the bean somehow. That's something you can do. If you have used stereotype annotations like I did here, then you would have to go here and add the qualifier to give a particular name to this class, and then you go with the same qualifier annotation to say what exactly you want to inject here in this parameter. Or in case you have used the bean annotation, you have to go over the bean method. That's how you can use it. Whether I want to use it or not, always, of course, I prefer to avoid using it if I don't need. So, for example, if I have only one implementation, then yeah, I could use qualifier, but no, I don't use it because it doesn't make sense for me. I mean, it doesn't really make sense for me just to use qualifier because I want to change the name of the bean or something like that, if that was the question. So I try to keep things simple in this case, and I do use qualifier only where I do need it for something. And then why can't do auto-wired private repository, new repository? Not sure exactly the question, what you mean by that. So why we can't do auto-wired private repository? There are 3 ways in which we can use auto-wired. One of them is using it on the field here, but then you have to remove the final, because if you use it on the field, then auto-wiring needs to happen after the constructor has been called, and then you would not be able to have the final, you would not be able to have the attributes final anymore. You can use it like I'm using it here, and then of course I can omit using auto-wired annotation because Spring, starting with version 4 something, if I correctly remember, knows that I want to do auto wiring even if I don't place the auto wired annotation, just because I have only one constructor. And then you have the setter injection, which is very rarely used. So you can use the one on the field, but it's not recommended. Maybe that's what you want to say. Why isn't that recommended? First of all, it's not recommended because you cannot ensure the immutability anymore. I was just telling you have to remove the final here, because if you put the auto wired on the field, then you have to have a mutable variable so that Spring can inject the value after the object has been created already. And then the second purpose why this constructor is preferred over the field injection is because it's also easier for unit tests. And somewhere here at the end of the book, we'll discuss about testing, which will also answer one of the previous questions. And then I will tell you a little bit more at that time why the constructor auto wiring helps you with better, easier writing unit tests. Okay, so I hope that at least answer the part of the question, and if not, I remind you that in the previous chapters we discussed a little bit more in details about wiring bins, so maybe you want to go to chapter 3 again and review what we have discussed at the time about the 3 ways in which you can use the auto wired. Okay, going further, so I'm proving here that this is working. I'm not gonna go again through. I mean, this book comes with all the code, and the code is free. You can get it straight from the main page of Manning. You don't have to pay for it. I even have one of the projects here, so this is how it looks like. So you can see this is exactly the code from the chapter. You see the comment and the notification proxy. So I'm using the interfaces here, as you can see, and I have the classes that define the implementations. No, so db comment repository implements comments repository and overrides the store comment method to give it an implementation. And of course, you might see here that in this is actually my projects come in steps. Now, if you have read this book and went through the projects, you saw that I do create multiple projects for different examples to make it easier. And being the last one, this is, you see, basically the exactly last project of the chapter, and you might have spotted here that in the book that I've been parsing, I have been using component here, and then in my IntelliJ I'm using at repository. And you might wonder why I'm using at repository, because we didn't discuss about it, but that's basically what section 4.3 here is all about, and that's basically what we are going to discuss now. And why do we do that? So pretty easy actually. No, just the only thing you need to understand, the only thing to get from this section is that you can use interfaces first of all, and then secondly, be mindful to when you use interfaces, because not every class in your project needs to be needs to have a contract. No, remember that contracts make sense when you have different implementations, and if you don't have this situation where you potentially have different implementations, it doesn't make sense just to create an interface. So that's why creating interfaces for service classes, which is something that you might see commonly used in real world applications, it's not something okay. I would not call it an anti-pattern, but at least a code smell. Oh well, you might then ask, hey, if it is a code smell, why the heck do I see it in real world applications? And the answer is because real world applications are not necessarily perfect either, no? And that many developers sometimes make mistakes or take wrong decisions, and sometimes maybe they get propagated. In many cases, I've seen mistakes coming from different articles or answers posted, for example, on platforms such as Stack Overflow, no, or different similar blogs, no. Someone asks a question, somebody else's answers, it comes with an answer that works, but it's not perfect, but then it's copy pasted and it's used as is. And my advice, of course, and this is an advice, you will hear me, maybe you've heard me in other videos saying the same thing, because it's important. Whenever you use any tool, whether it's ChatGPT, any other bot, or any other AI agent, Stack Overflow, and or any other blog or forum, remember to always take that whatever response you get or responses, understand them properly first, research a little bit, and only after that use them and modify them in the right way. Don't just copy a response and use it, even if it looks like it's working, because something that's working in software development, it's not necessarily something that is all of it good. Okay, that's a very important advice for absolutely everyone. Different mistakes, I can even give you examples of different mistakes that I see introduced in projects because of people, of developers in the past, taking the approach of copy pasting things as they are without researching them first. I saw people using, for example, still using the date class from Java util, even in recent projects, even if we shouldn't use it for a long time already. I saw people using, for example, the bcrypt encoder and decoder classes from the package sun.something, sun.crypt or something, which we should never use because it's an internal package, and that actually even cost a very now it's a little bit more difficult to use it because with Java 9 you have the modules, the jigsaw modules, and they don't allow you to use internal classes anymore. But that was one of the causes creating the biggest problems when people had to go from Java 8 to a higher version, because we have discovered that in many cases, for reasons, developers used internal classes, and that's in most cases simply because that's the way they've seen on a certain answer of a blog, and it looked like it's working, but they didn't think, hey, am I doing the right thing? Am I implementing the latest approach when doing something like that? And even vulnerabilities with Spring Security at some point, because people didn't make the difference years ago when we had AND matchers versus MVC matchers, and a lot of people were simply using AND matchers because there were plenty of examples with AND matchers because they were introduced earlier than MVC matchers, and they didn't understand that AND matchers, they are a bit different than MVC matchers. So many, you don't have to understand all of this. No, I'm just giving you examples throughout the many past years of my experience, just telling you all these were introduced because developers didn't pay enough attention. Okay, so that's the same case here. Why do we discuss everything else but the art of transforming our idea into code reality as much? Give me a little bit more details on what you mean with that. Maybe ping me on LinkedIn, and if that's something cool, we can even create a playlist about that. No? So that sounds interesting. I don't know if I understand it correctly, but sounds really interesting. So give me more ideas about that. Okay, let's go even further. Let's finish this chapter. We don't have so much time left, no? So you understood hopefully this and how it's working, and different ways of using dependency injection with abstraction. I'm going now. Maybe this actually answers the question about the field. No, I have this sidebar here where I demonstrate again that auto wiring on the field works, and probably the setter works also with abstractions. But remember, in real world applications, in the development side, you should use the constructor dependency injection. And then let's quickly go through the example proving what should you do when you have multiple implementations, because I have already told you about primary and qualifier, and of course being important parts of the dependency injection, I have put them in the book as well. So in the section 4.2.2, you have an example of how you can use the primary and the qualifier. So if you have more than one implementation to an interface, of course, Spring will not know, cannot know, if you don't tell it somehow which implementation should it use. If you simply just declare the contract, but you have more implementations of the same contract, it will create confusion for Spring. So you need to tell it which exactly of those implementations should you use. And there are two ways now, these two ways here, these two bullet points, either using the primary annotation to set one of them as a default, or using the qualifier to use dependency injection by name. So you just give a name to the bean and then you use that name. And we are into the same example, no? But then if you add just one more, say push notification, no, we had the email notification proxy, and I was telling you might have multiple, and no, you really might have multiple implementations, because we've started with the idea of using interfaces, contracts, when you have potentially more than one implementation. Otherwise, no, it doesn't make sense. And then of course you get into this situation. So what happens? The book tells you what happens here if you have added one more class implementing the same interface. And then of course, if you do that and then try to run the same code, you will get this message, which is fortunately for us very easy to understand. So I do see that Spring team worked a lot on messages, on exception messages, which is very, very nice and comfortable, because most of the messages, when something like this happens, tell you immediately what something happens. So for example, it tells you it expected a matching bean but found two, and it even gives you the two beans, the names of the two, the identifiers of the two beans in the Spring context, in this case, causing the problem. So it actually tells you, hey, I have a comment push notification proxy and an email comment notification proxy, and both of them are instances of classes implementing the same interface comment notification proxy. What would you like me to do? Which of these two should I inject in the field you defined using the contract? And then you either have to go on one of the classes and use the primary annotation, or over the bean annotated method, in case you've used bean annotation instead of stereotype annotation. And then it will simply work, because automatically that primary annotated class will become a default. Or you define a name for each of them and then you use the name. So you see here, instead of using the primary annotation, you go over the two classes, you give them of course different names. It wouldn't make sense to be the same, no, then you would get into the same problem. And then you come with the qualifier annotation exactly where you want to inject the value, which are, in our case, because we are using constructor dependency injection, will be the constructor parameter. And then again, depending on what you specifically decided to inject, that one will be the one that is injected. And you see here in the code snippet, this is the output of the application, which proves that the push notification comment was the one injected, because that's what we have requested. And then before going to 4.3, let me I see some more messages. Thank you very much for being so active. I'm so happy to be back here and see so many people active. I would have been a little bit sad to not see so many people here with me. So something like the junior Java dev interview. I remember that. Yeah, it was like a few years, a couple of years, or maybe 3 years ago, when I tried that. And now you want actually to do something very similar, but with a junior dev. So you want me to play the junior dev, and someone asked me the questions. Great, very great idea. I will plan it as one of the next videos. So, and then something cool, how can we come up with an idea and come up with solutions? Okay, so now I understand. So it actually sounds very cool to me. So another playlist from your point of view would be how to think as a software engineer, no? So how to step from the only knowing a language to be solution first driven, something like that. So how do you think about ideas, solutions, algorithms, and architectures? Okay, cool, thank you very much. Yes, I actually have to put down this, and I'm gonna quickly take some time to put down. So we had the junior interview, and then say developer to engineer playlist, and then I had some more ideas with Kafka and so on. I will take the chat later. Cool. Good. Let's go further and also discuss this very simple section 4.3 and end today's episode with that, because we will finish chapter 4. So this will give us the chance in the next episode to discuss chapter 5 about the bean scopes and the life cycle, and with this finish everything about the Spring context, a very important and essential part for any Spring developer to correctly understand how the Spring context works. I know it might look boring, it's all these technicalities, but learn them well and you will make a difference between you and others who don't properly understand how Spring works behind the scenes. So what I want to tell you in this 4.3 with responsibilities with stereotype annotations for specific responsibilities. I mean, it's what you have seen here. No, I've changed in the last project the component stereotype annotation with a repository here, and if we go to the services, you'll also see that I've changed it with the service annotation. And then you might wonder, hey, why have I done something like that? Why did I change it like that? Because component is a very generic stereotype annotation. It works, you can use it everywhere, but there is one more thing, one more layer that we always add in the design of our application. That's the documentation layer. So one of the things is make sure that we correctly annotate our beans, not only in terms of making them beans, but also documenting what kind of beans they are. And you have 3 different, with component 4 different stereotype annotations that you will see used in real world applications. So is the add component, service, repository, and controller. For some of them, using a specific stereotype annotation might even work differently. For example, at controller, it's something that I will discuss when we talk about web applications a little bit later in the book. So I think it's chapter 7. Here is where we will discuss, we will introduce also the controller, and then later on in chapter 10 we'll discuss about REST controller. This also creates a bean, but it makes it a controller which makes sense for a web application. I'm not going into details now because we'll discuss it in detail later. But for any kind of application, when you put at repository over a class, it means that one is an implementation for persisting data. You can even persist data in a file. It doesn't matter. I'm simply talking about persisting data. Of course, normally today in real world applications, it's all about the databases of a kind of another. So when you see at repository, most likely it's about the database. But in general, it's about persisting data, okay? So use at repository over an implementation where you persist data in a way or another, making that specific bean what we call in today's applications design a repository. At the same time, use at service instead of component on classes implementing business logic and use cases. So just keep in mind that it is a good practice to not only use a stereotype annotation, but use a stereotype annotation of a specific type to also present it with the right documented purpose of a given bean. That's why in real-world applications, you don't see just add component everywhere. You just use the add component generic when you have a bean of a kind, but it's not something like a service or a repository or a controller. But if it's one of these three, which are main actors into the class design of an application, then recommended is you use at repository, at service, and controller, wherever you need that. And some more messages. Whoa, I've just turned by my head a couple of minutes and something happened here. So before starting the Spring Security, you understand the Spring Boot, but before starting Spring Boot, you understand Spring Framework. Correct. I mean, if that was a path, yes, Java fundamentals are the first. And then you have to work with Spring. I don't necessarily say JPA and Hibernate have to be like before, but you can take them in parallel. But yes, very important, understand Spring basics first before Spring Boot, and then all the modules, like all the other projects like Spring Security, Spring Batch, and so on, after you have all the core knowledge about that. Okay, good. So no questions. I'm very happy that you are discussing between yourself, because I want to create as much as possible this as a community. So from now on, I will search also for different ways of making people interact better with each other and not only with me. And going back, I think I only have one more thing to tell you before going further. No, because we finally are here at the summary. The end of this chapter 4. The at repository, there is one more thing to discuss about the at repository interface and the at repository annotation, and I'm referring here to putting it correctly. If you will go into my example here, you will see that I have used it as well. And you can see that I have used it on the class implementing, in my case, the repository example. Any stereotype annotation, any of them, component, service, repository, controller, and the REST controller mix that we will discuss a little later, they are only meant to be placed on classes. You can put it on an interface as well. So for example, can I come here and use the at repository, at repository annotation? Syntactically, yes, because the target for this is type. And this cannot interfere anyhow with using it on any structure in Java defining a type, which is interface enum record class, abstract class. But it doesn't make sense. Never use at repository or any other stereotype annotation on an interface or on an abstract class. It doesn't make sense, because what a stereotype annotation does, and this is something that we have discussed here in defining beans in chapter 2 is telling Spring that it has to create an instance of that class and putting it into the Spring context. So why doesn't a stereotype annotation, whatever stereotype annotation, why doesn't it make sense on an interface or on an abstract class? Because interfaces and abstract classes cannot create instances. They have a totally different purpose within the language. If you put there at repository over an interface, nothing will happen. I mean, it doesn't break the compilation, but it doesn't do anything either. It's just some annotation there that will help no one with nothing. In other words, it's a code smell. It's just some garbage, some small piece of garbage in the code that doesn't help. Our purpose to keep our code maintainable is, remember, to have the simplest solutions and minimize as much as possible the lines of code that we write. Otherwise, we run into more code, meaning the bigger difficulty of maintaining it. This is an anti-pattern I see often, because when using Spring Data, which we will also discuss here somewhere in part 2 of the book, you will see that Spring Data, of course, does exactly what it should do. It decouples using interfaces the implementation, which is done by it using dynamic proxies. Going into more details at that time, not now, okay, but I'm just trying to make an overview. And then for some reason, because people, again, don't necessarily understand very well the details, have the impression that they have to use a repository over the Spring Data repository interfaces, which is not the case. That's simply just not the case. You can just, trust me, delete that at repository, you will see nothing happens. Okay? It will still work and nothing bad happens in that case. Because that's basically just used there because developers saw it somewhere or simply didn't understand exactly how the repository annotation works and just use it, and that's it. Okay, so many more messages. I'm starting with the first one I haven't read. So you mentioned earlier you put a component annotation on the implementation, not in the exactly, okay? Exactly. Stereotype annotations, component, repository, service, controller should never be on interfaces or abstract classes. If you put them, it will, okay, not break the compilation, but do nothing either, okay? That's why we don't put them. So when do we place such annotations like a repository or interfaces? Never. You will only find them in applications where developers put them there because they didn't understand how a repository works. Okay? So at repository, even if you will find examples out there on the internet using at repository over interfaces of the Spring Data interfaces, don't use them. It's a wrong example, okay? It's not breaking anything, but it's not bringing anything useful either. It's just code smells. So making a Discord community, I saw the messages about Discord and I'm planning of making a Discord community. So I will come later with some more details about that. To make a Q&A interactive live, of course, I actually did some Q&As in the past, so I did have some Q&As as well, but I will make more, no worries. So that's one of the things we can plan for one of the next videos as well, for whatever random questions you have, of course, and just as a discussion and spend our time together, maybe have a coffee together and talk about whatever you want to talk. Kafka, other questions, okay. JVM architecture, very good topic, but very difficult. I will consider it. However, I don't even know if I myself know enough well the JVM architecture. I'll be very honest with you. I have to see, and especially whatever changed, and then think about it's not that easy, you know, because you don't have one JVM, you have multiple JVMs. And for example, Graal VM is different, works differently than other JVMs. So it's a very tough topic, but I will consider it. Yeah. And the Discord channel. Yeah. And with that being said, friends, look, it's almost 1 hour us chatting together here, and our time is over for today. But of course, I'm here and I'm finally back, and I'm looking forward to discuss a lot more things with you. Thank you very much, everyone, for being here with me again, and for being so active in the chat and everything. And hope to see you in any of the next live events that we'll create together. And looking forward, of course, to your questions, comments, and everything on LinkedIn, on Blue Sky, and other social media accounts that I have. Until next time we meet, I'm waving goodbye, and thank you very much again, everyone. Take your time learning further, and have a good rest of the time.